Hello, I'm Yusuf Anas. I'm the leader of E-JUST Robotics Club Team A, and this is our team.
I'm Heba Khalil, a mechanical team member. For the design of our team, we are using 6 wheels. 4 of them are connected to the motors. The motors we are using are 110 RPM and 15 volt. For the other 2 wheels, we are using encoders. The encoders help us to facilitate the movement of the robot in the desert environment and getting more accurate readings. For the chassis, we are using double membrane rods. This helps us to get less weight with rigidity, and this bears the weight of the battery we are using and the other components. For the base of the chassis, we are using MDF wood, and it's supported by 2 rods to make the robot more stable. For the gripper, we are using electromagnets that is connected to an arm with free movement that capture the mine and collect it in a net. Then we are using a sensor or a metal detector that is connected with a PVC rods.
My name is Abdulrahman Leila, the electrical team member. Concerning the power and control circuit, we use the 12-volt acid battery connected to the 2 Switcher motor drivers, which are connected to the Raspberry Pi, alongside with the IMU sensor and the encoders. And for the Arduino, it supplies the power for the proximity sensor, a metal detector, and the servo motors. But what about how the robot detects landmines? When the robot moves in the field, when the metal detector senses any metallic object within its sensing range, the proximity sensor operates and checks whether there's an object on the ground or not. If there is an object on the ground, which refers to the surface mines, the arm goes down and collects the mines and take it back to the container. And for the communication between the station, the control station, which is the laptop, and the robot in the field, we use a Wi-Fi access point in order to communicate between them.
The heart of the robot software is the Raspberry Pi, which acts as the main controller. The Raspberry Pi is equipped with encoders and IMU sensor, which allows us to perform sensor fusion using Kalman filter to determine the robot and mine's position. When a mine is detected, its position is sent to the laptop as a vector form, and then a graphical map is shown. Our robot has multiple systems, which was possibly integrated using ROS. We have created separate nodes for each purpose and integrate them at the end.
There is a node for manual control that publish velocity commands from the laptop to the Raspberry Pi. In addition, a ROS serial node which facilitates the communication between the Raspberry Pi and Arduino.